Okay, so now this is a specific type of stoichiometry. It's called gravimetric. Okay, so which one do you think it might be about? Solids, liquids, or gases? Just take a guess. Yeah, good guess. Okay. So gravimetric, that word means mass measurements. So generally when we're measuring mass, we think of measuring a solid. So, to solve a stoichiometry equation, or question, these are the steps that you have to do because it might not have it all written out and laid out for you. Okay? So really important. Got it? First step, write a balanced equation. Super important that it's balanced. That's the whole key. Including states. Okay, sorry. Write the information given. I don't know what's super off-centered there. Write the information given. Find the moles of the given species. And when it talks about species, it means like either the compound or the element. It's not like, is it a polar bear? Is it a grizzly bear? Is it a pizzly bear? You know, it's not like, okay? So you can use your N equals mass over molar mass to find that. Then find the moles of the wanted species using mole ratio, which is wanted over given. Wanted over given. Next, okay, so that's our mole ratio, wanted over given. Lastly, calculate the mass of the wanted species using M is equal to N times big M. So before you flip it, I just want to make a big picture idea here for you. Okay? So, yeah, I did. Okay. So again, let's go back to this idea of just looking at reactants to products. So say you are given the mass about a product or just any species, and you're asked to find the mass of another species. So this is kind of like a map. Okay? Ready? This is the map to all gravimetric Stoich problems. So say you were given information about reactants. You would be given it in the form of a mass for gravimetric questions. You need to find the moles. What's the formula? Little m over big M? So then you get a value in moles. Now this is what I always think about. I think about finding the moles of one side, and then I compare doing wanted over given. So you take your given moles multiplied by wanted over given ratio. Okay? Whatever moles you get, mole wanted, now you can put it here. Then you solve for M using N times big M. Okay? That's your map. Okay? You always need to find moles to do any sort of comparison though. You can't compare with masses. Eh? Okay. I know it might seem simple to you now, and if it does, that's awesome, okay? Because some students, they don't figure this map kind of idea out until like halfway through the unit, okay? So if you can kind of get an idea of this map idea, like find the moles of one thing, do a comparison, find the moles of the next, you'll be cruising, okay? If it's a struggle for you, that's okay too. But if you're finding it this easy, then that is good for you. But if you don't, that's okay too. All levels of understanding are welcome. Okay, so let's do an example where we kind of put this into practice. So, you're told iron is produced by the reaction of iron 3 oxide with carbon monoxide to produce iron and carbon dioxide. What mass of iron 3 oxide is required to produce 1,000 grams of iron? Okay, so that sounds like a whole bunch of gibberish, right? If you don't put it into a chemical formula. So what you need to start with is writing a chemical formula with what you are given. Now this is where the foundations from Science 10 will really be applied, because remember how much I made you guys practice doing formulas in grade 10? It was painful, right? But now you will be cruising. So take out your periodic table to help you, because you need to know your charges to make your compounds. You'll need to remember things about carbon monoxide, carbon dioxide. And we write out, so include states, okay? Now think about states where if they're pure at room temperature, okay? So don't look at the bless you. Don't look at the solubility. Just think about if it's an ionic compound at room temperature, it's solid. So iron 3 oxide will make Fe2O3. Added to carbon monoxide gas will make iron solid and CO2 gas. So now you have to balance it. So if we think, initially, there's 2 irons on this side and 1 on this side. Okay, so add a 2 there. My carbons are good, but on this side I have 4 oxygen and 2 oxygen here. So if I put a 2 here, I have 4. If I put a 2, then I have to put a 2 there. So then I have 2 carbons. Does that work? Nope. So then, did I say I put a 2 there? I can't do this without. Okay, so if I put, okay, so it ends up being 3 and 3 for your CO2. But I'll maybe just do this manually too. So if we have Fe2O3 plus CO, Fe plus CO2. So remember, if you're balancing, draw your line down the middle and do things on both sides, so that you don't make mistakes like I was. So Fe, I got 2, got 1, I got 4, I got 2, got 1, I got 1. Okay, so I'll say I put a 2 there. I got 1, 2, 3, so I put a 2 there. So now I have 4. Now I have 2 here. So if I put a 2 there, it won't work. So if I put a 3, so now I have 3 carbons, and I have 6 on this side. Put a 3 there. Now I have 6. Okay. All right. So once you get it balanced, then you say, what am I given, and what do I want? You label that first thing. So you're given information about your iron. Your given information is mass of 1,000 grams. Convert it into moles. So your molar mass is 55.85 grams per mole. Your wanted is your iron 3 oxide.
Do you have to multiply your molar mass times 2 because you have 2 FEs?
No. You only multiply your molar mass by 2 if like there was a 2 here. It's saying that there's 2 like not molecules, but 2 of iron elements. But if you took one of those, how many would you have? You just have 1. So it's like, you know, for CO2, if you looked at 1 molecule of CO2, you still have 2 oxygens. Yeah, good question. Okay, so to find our moles of our given, we go N equals little m over big M. So 1,000 grams divided by 55.85 grams per mole. So that's quite a bit. It's a pretty big number, which makes sense because we have 1,000 grams. So 17.90, etc. moles. And carry as much as you can throughout your calculators, like till you get to the end. So now on our map, what we found is we found our moles of our given. So now we do a comparison, and then we can find to get our moles of our wanted, and then find our mass. So our comparison is taking our given moles multiplied by wanted over given mole ratios or mole coefficients. So our moles of our wanted is 8.95, etc. moles. But we were asked to find out the mass of that. Okay, so it says how much mass. So I need to put that into mass. So with that molar mass, you times the Fe by 2 and the O by 3 to find it. So our mass is equal to N times big M. You end up with 1,429.725 grams. But that's not in sig digs. So we got to put that into sig digs. Well, we actually have 4 sig digs here to work with, which is kind of nice. So it rounds up to 1,430 grams. That's a lot. But if we need to make 1,000 grams of iron,